Welcome to Tennessee's At Home Learning Series. Today's lesson is for all of our fourth graders out there, even though everyone's welcome to tune in. If you haven't caught our previous lessons, you can still watch today's, but I do recommend getting on the www.tennessee.gov/education website where you can find the previously recorded lessons so that you don't feel behind because it might pick up on some things that we've discussed in our previous lessons. My name is Miss Pereira, and I'm a fourth grade teacher at Venus Stewart Elementary here in Gallatin, Tennessee. I will be your virtual learning teacher for today. Thank you for inviting me into your home and welcome to my virtual classroom. We're going to continue our work with composing fractions and begin to think about adding fractions. A fraction is a number that names equal parts of a whole. We will also think about how we can model our thinking about these fractions using drawings or number lines. So let's start today as a warm-up just by looking at two fraction expressions. An expression is simply minus the equal sign. An equal sign, it becomes an equation, and when it doesn't have an equal sign, it's just an expression. So let's look at this expression. Let's look at 1/5 plus 1/5 plus 1/5. That's one of the expressions we're going to look at, and the other expression is 1/5 plus 2/5. So let's look at how we could model these with a picture. I'm going to draw a rectangle, and I want you to think about if I was going to model this 1/5 plus 1/5 plus 1/5, how many equal parts do I need in my model? Correct, 5. Because the denominator is 5, I know that my whole has been split into 5 equal pieces. One, two, three, four, 5 equal pieces in the whole thing. So what fraction would name this one piece? Correct, 1/5. What fraction would name this one piece? Correct, 1/5. So each one of these sections or parts represent 1/5 of the whole, that idea of the unit fraction. And let's do some shading to model this expression, 1/5 plus 1/5 plus 1/5. So 1/5 plus 1/5 plus 1/5. So when I put it all together, I can see I have a total of 3 of those 1/5 pieces for a total of 3/5. So I can now turn it into an equation because I now have a total or a sum. Let's look at this expression, 1/5 plus 2/5. If we were going to draw a model for this, how many equal pieces do we need in that model? Correct. Again, we need 5. Because both fractions have a denominator of 5, so I know that there's 5 equal pieces in the whole. So I've got my 5 equal pieces, 1, 2, 3, 4, 5. Just as we discussed in the problem above, I know that each one of those sections represents 1/5 of the whole. And this time my shading, I'm going to shade 1/5. Plus, I'm going to shade 2/5. So altogether, how much of my whole piece is shaded? Correct, 3/5, because it's 3 of those 1/5 pieces that have been shaded all together. So look at these two now equations. What is the same about them? Correct, they both represent the same value. They both represent a total of 3/5. They also both have fifths in the denominator. So what's different? Great job. Yes, they both have the same total, but the add-ins or numbers that we add together are different. This time we added 3/1/5, and in this one we added a 1/5 with a 2/5. Great job getting your brains warmed up, and we're ready to dive on in with a word problem right off the bat today. So I'm going to show it to you. Read it with me, please. Josie and Margot are painting a fence green. Josie starts at one end and paints 3/10 of the fence. Margot starts at the other end and paints 4/10 of it. What fraction of the fence do they paint all together? So let's ask ourselves, what do we know? What do we need to know? And let's go back and let's dig in a little deeper on that second reread. So we know we've got Josie and Margot painting. We know that Josie starts at one side and paints 3/10 of the fence. We know that Margot starts on the other side of the fence and paints 4/10 of it. What do we need to know? We need to know what fraction of the fence do they paint all together. So we're trying to put each piece of the fence that they painted separately together to see how much they painted in total. So let's pull out some important information. So that way we don't have to go back and keep reading and reading and reading. We know that Josie, and you can write this down with me, painted how much of the fence? Correct, 3/10 of the fence. And we know that Margot painted how much? 4/10 of the fence. And we're trying to find out how much did they paint all together. So let's draw a model to help us out. Let's draw a rectangle because a fence is represented well with a rectangle. So let's draw a rectangle. And then as you're drawing your rectangle, think about how many equal pieces are we going to need to split our rectangle or our fence into. Josie painted 3/10. Margot painted 4/10. So how many equal parts do I need to divide this whole piece up into? Correct, tenths, because they both have a denominator of 10. So they split the fence up into 10 equal pieces, and then they went back and painted some of those pieces. So I like to start with fifths just so I can make sure I'm getting my pieces as equal looking as I can. I know it's just a sketch, but I want it to look like equal pieces. So there's fifths, and then I'm going to split those in half to give me tenths. So I should have 10 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. Now, what fraction of the whole fence is one of these pieces? Correct, 1/10. Each piece on its own represents 1/10 of the whole. That unit fraction that's going to help us build or compose how much Josie painted and Margot painted. Now we can shade in our model to really show what part each person painted. So it said Josie started at one side and painted 3/10. So she painted 3 of those 1/10 pieces. So shade yours in with me. So we know that she painted 3/10 of the fence. And it told us that Margot started on the other side and painted 4/10. So shade with me to represent how much Margot painted. 4 of those 1/10 pieces represents 4/10. So the question wants to know what fraction of the fence did they paint all together? So I'm not finished yet. Yes, we modeled what the problem said, but we haven't really solved the problem yet. So now we need to put them together. How much of the fence did they paint all together? Well, I can see that they painted 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10. Or they painted 3/10 plus 4/10, so that all together they can say they painted 7/10 of the fence. Great job. So it asks us a question, so let's answer in a statement. They painted 7/10 of the fence all together. So that's one way that we could have modeled this problem and finding a solution. We could also model this with a number line, which is something new that we're going to introduce today. So thinking about a number line, how many pieces do I need to break my number line up into? Correct, 10. Just like I broke this model up into 10 equal pieces, I'm only dealing with one whole. I've got one fence broken up into 10 equal parts. So sketch this with me. If you've got lined paper, try to trace over a line on your paper so that your number line can be as straight as possible, and probably draw it as big as the whole paper because we need 10 equal pieces. So we're going to have to break this number line up quite a bit. So number lines always have arrows because they're a number line, and we know numbers go on and on forever. We always have to have a starting point and an end point. Of one hole in this case, because we're only dealing with one fence. And then I'm going to take that fence and I'm going to divide it up into tenths. Again, I like to start dividing it up into fifths and then go back and split those pieces in half. So we're going to divide that up with just tick marks. And then my fifth tick mark is actually going to be on this one hole. And so we're looking at the space between the tick mark. So we're going to go back and divide those in half. And we can see that from here to here is a section of the fence. From here to here is a 1/10 section. From here to here is a 1/10 section. And so on, all the way down our number line. So now we're going to go back through and label our tick marks. So we have 0 fence. And then as we move up our number line, we will have covered 1/10 of our fence. Now we know as we go up on a number line, our numbers get bigger. So once we move up to the next part, we've now went across 2/10 of our fence. Going on to the next part, 3/10, and so on all the way up until we have one whole fence, or 10/10. I'll give you just a second to finish drawing your number line. I know it can take a little bit of practice to get the number line down. The neater that you write, the easier it's going to be to use this tool or this model. So this time, instead of doing some shading, we're going to mark points on our number line. So we know that Josie painted 3/10 of our fence. So we're going to go to our number line. We're going to find 3/10, and we're going to put a dot there to mark how much Josie painted. Then we know that Marco painted 4 more tenths. So we're going to take some hops, some 1/10 hops up our number line 4 times. So 3/10 plus 1/10, 2/10, 3/10, 4/10. And once we go up our number line 4 more tenths, we can see that we land at 7/10, which is the total amount of fence that they painted all together. Okay, so let's review what we just did. What number tells the total amount of equal parts in either model? Correct, 10. That denominator is an important piece of information in a fraction. It tells us the total amount of equal parts in our whole. What does the numerator tell us? Well, the numerator tells us how many pieces of the whole that Josie painted, how many pieces of the whole that Margot painted. And in this case, how many pieces of the whole they painted all together. So when we're adding fractions with like denominators, we can see that we simply add the numerators and leave the denominator. And that's because the pieces in the whole stay the same. They don't change size. So that's why our denominator stays the same. Okay, let's look at some more practice together. Another word problem that we're going to do. Read it with me. Lita and Otis help their mom clean the house. Lita cleans 1/3 of the house. Otis cleans 1/3 of the house. What fraction of the house do Lita and Otis clean all together? What do we know? What do we need to know? So we know that Lita cleans 1/3. We know that Otis cleans 1/3. And we're trying to find out what fraction of the house do they clean together. So let's pull out our information and draw a model to help us solve this one. We know that Lita, I'm going to split my paper into 3 columns because we're going to work 3 problems. So we know that Lita cleaned 1/3, and we know that Otis cleaned 1/3. I'm going to do that in a different color. So if we were going to draw a model, how many equal pieces do we need in the whole? Correct, 3, because our denominator tells us how many equal pieces we have in the whole thing. So they took their house and they split it up into 3 equal parts. And we know that Lita cleaned this part, and we know that Otis cleaned this part. They each cleaned 1/3. So what fraction of the whole did they clean? We would need to add these two together, and we could see that they cleaned 2/3 of the whole house. Okay, the next one I'm going to give you a little less help with. I want to see what you're starting to learn and what you can do on your own. So let's read the problem together. Mark and Amani use string for a project. Mark's string is 1/5 of a meter long. Amani's string is 3/5 of a meter long. How long are the two strings combined? So a meter is a unit of measurement in the metric system, kind of like a yardstick. So can you picture that in your head? Mark's string is 1/5 of a meter long. Amani's string is 3/5 of a meter long. How long are the two strings combined? So let's pull out our information that we need to solve, and then I want you to find the solution. So Mark used 1/5 of a meter of string. Amani used 3/5 of a meter of string. And it wants to know how much string they used all together. So I would suggest doing a number line for this one. And because our denominators are a 5, we know that they had broke that meter up into 5 equal pieces. So give yourself a starting point. Go through and divide your number line up. Label your tick marks. And then you use the model to see if you can find out how much string they used all together. Great job. So we can mark on our number line how much string Mark used. He used 1/5 a meter of string. And then we know that Amani used 3 more fifths. So we need to go up on our number line 3 of those 1/5 pieces. So 1/5, 2/5, 3/5. So we can see that together they used 4/5 meter of string. So they used 4/5 meter of string all together. Okay, the last one I'm going to let you do all on your own, and then we'll check it together. You can choose your model. If you want to do a drawing like this or a number line, whatever works best for you. Here's the problem. Paola makes a fruit smoothie. She uses 2/8 of a pound of strawberries and 4/8 of a pound of blueberries. How many pounds of fruit does she use? So I'm going to give you about a minute and a half to work this problem. All right, great job. Let's check our work together. You know by now I like to pull out the important information. So I'm going to write strawberries. And it told me that she used 2/8 of a pound. Blueberries, she used 4/8 of a pound. And it wants to know how many pounds of fruit does she use altogether. So I'm going to draw a model. Woo, barely fitting on my page. And I'm going to divide it into eighths because my denominator in both fractions is eighths. We're looking at 1 whole pound. So I'm going to split in half, and I'm going to split my halves in half. Then I'm going to split my fourths in half, and that gives me eighths. And I know that she used 2/8, so 2 of those 1/8 pieces of strawberries, 4/8 of blueberries, so 4 of those 1/8 pieces, for a total of 6/8. Great job. The last thing I'm going to leave you with is some independent practice that you can go do on your own. Take a picture of the screen, or you can also go online at www.tennessee.gov/education to find these where you can print them out. You're going to use this diagram to answer these 3 questions. And then you're going to use this information to answer the next 4 through 8. Thank you for having me in your house again today. I really appreciated learning with you today. You all worked very hard. I look forward to seeing you in our next Tennessee at Home learning series as we continue to work on fractions.
The value parents place on reading makes a big difference in a child's reading and language development. You don't have to be a teacher or a great reader to create and nurture a love of reading in your child. It's beyond words on a page. It's about using stories to engage your child in the world around them. Start early because language development begins at birth. Exposing children to books early enriches their daily lives and builds strong thinkers. Just having books in the home, no matter your comfort level in reading aloud, can help a child grow to love reading and learning. Let your baby touch, feel, and even chew on the books.
Bah, said Gregory unhappily. Let me see your unhappy face.
Ask your child questions about the book and experiences the characters are having. Use the pictures to spark meaningful, engaging conversation, relating pictures to things in the child's day-to-day routine. Share the joy of books by bringing the story to life. Read with enthusiasm and energy in any language. Try using different voices for different characters.
Is that we're all here together?
Make up a funny story using the pictures, or act out characters and sounds animals make.
Hey.
Encourage your child to copy you and make his or her own noises.
That's good.
And most of all, reading with children and exposing them to books from the moment they're born instills an everlasting love of reading and learning that they'll have for the rest of their lives.